So, dear audience, we've heard today a lot architects speaking about architects and themselves and other architects, but we all know that we are not alone and we can't get a good architecture without help of another people, without their expertise and their experience and techniques. And that's why today I introduce you to a man who have been in the glass business already over 30 years, and who is familiar with production as well as with design, and who has handled over 40 glass facade projects over the world. And some say he has a passion of the visual aspects of glass, and that he is the master of the glass facade detailing. So I present to you today Saint-Gobain Glass Technical Specification Manager, Oskar Storm. The floor is yours.
Thank you. I'm so honored to be invited here today. And to present myself, I can say that my middle name is Gunnar. And I never used to like it. But today it became a bit more comfortable, actually. Oskar Storm is my name, and I worked so hard to transmit the message of Saint-Gobain over the last 10 years in specification for Sweden and Norway that I am the first hit on Google for my name, which makes me easy to find. And I've also written a book. Oops. I brought a few copies with me, so if anybody wants it. Otherwise, it can be downloaded for free on my landing page. So, Saint-Gobain is about sustainability and innovation. And I want to start by presenting that, but not as products, but as concepts. Ways of applying these things. And then also touch upon how general or specific is Saint-Gobain as a glass producer? How much do you lock yourself in with the Saint-Gobain specification? And then I focused on, the question was before, what is the biggest challenge of daylight? And I would say, or light, I would say it's thermal comfort, overheating, meeting energy standards. And so I want to discuss different roads to daylight and thermal comfort with a combination of glass and shadings. And then to discuss some new factors that I've thought about when it comes to how much window can you have in a wall? What window-wall ratio can you achieve? And also, in the end, to touch on the newer low-carbon products that are coming, that are here. So, before talking about applications, I want to say that I talk about DGU, which is double glass units, and TGU, which are triple glass units. And I want to have examples of retail applications, residential applications, and commercial applications. Starting with retail, this is really where innovation comes in. Back in the 1980s, Saint-Gobain invented the low iron non-green glass for the glass pyramids at the Louvre Museum in Paris. And that creates the whiteness of an image through the glass. And then a few years ago, we developed a low E coating called E-Glass, which is a laser-treated coating. And it, like so many solar control and energy glasses today, it takes away the reflection from the glass. But this one does it without really changing the color. So it's not yellowish or anything, it's really white. And so when looking at this store in Stockholm, it's the H&M signature store. We had the logo removed because they didn't want to have it displayed. But it was single glass, and with the energy demands on the on the renovation, it went to double glass. So here's like the recipe. So it's actually 2 low E coatings and 32 millimeters of glass that you look through here. But it creates the image of a single glass, and the single glass has always been the shop front to get the view to the inside. This sounds easy, but if you do it the wrong way, you specify, I think low iron glass is correct for my shop front, then you can, in the same store chain in Malmö, the low E glass is instead very high reflective, because there are such as well. And here you can just, you know, can you see the girl in there? There's a nose and a mouth. So leaving that, going on to residential buildings, we want big windows instead of big cars today, and we want a perfect view to outside. And then we're concerned with overheating. So we need to find some compromises there. And this is a project in Jönköping which has the lightest solar control glass on the market, together with this other low E glass. It really limits the amount of heat that comes in without really affecting the view to outside. So I think this is a new way to look at residential buildings, to add a bit of solar control in the glass. And here we can see the difference. There's an open door. I never had a green laser before. If I pointed at any of you, I mean, it's going to be prison for me. So I won't, I promise. The glass is also used in a very nice museum in Stockholm. It's one of those globe-sized cinemas, so hidden behind this roof. And here we can see that with the light coming in from 2 directions, with this glass, we get like a feeling that it's not at all about solar control, that it's just about transparency. And this is a picture taken from the inside of that building, Wisdom, which also shows a bit of like where is the glass. And the most fascinating, this won a very prestigious award last year, and the most fascinating picture from it is this one, where I need the pointer again. Here you see through 2 windows because it's a corner. Here is a reflection, and here is just a view of the building. And what you can see here is that the light is corrupted a bit by the glass, in that to take away the infrared heat from the glass, you need to cut through the visible red light. So the image to the left, to the right, it's to the left here, it's to the right there. The image to the right is a little more bluish than the image to the left. Moving on to commercial buildings, and this doesn't look like clear glass at all, it looks like dark glass. But as the previous speaker said, that you only have so much daylight on the inside, and that means that when you have a really transparent glass and you see to the inside, it's dark. It's actually usually RAL 7043, which is called traffic gray. I like that word, because it sounds a bit boring, but it's not. This is when it's usually stuck for a while. There we go. So this is Oskar in Stockholm is the project name, and it's 3XN projects, a Danish architect. There is a detail that I didn't plan to mention, but you can see that the wood is a little more grayish here and not so much here where it's shaded. That's normal. It's a popular material called Akoya wood, and it lasts like forever. But what people usually don't understand that this color is the same as standard wood. Anyway, that was not meant to be in this. What was here is that it's a balance of a more efficient solar control glass together with inside shadings, which is like the model in Sweden since a few years back, and it works really well. It also shows what happens when consultants come in, because up here there is no hat. I'm so surprised that there is nothing green down here. Anyway, there is no hat up here, so they needed a darker, more efficient solar control glass up above. And it's called the Extreme 6129. The only way you see it, they've been developed to have the same low reflection, the same neutral reflection. And you can see that the color on the blind is darker at the top than at the other one. It still gives like a very nice view to outside. And if you let light in through enough parts of the building, like this atrium in the old SAS headquarters in Stockholm, you can see that the solar control glass does not look any less transparent than any other glass. So this is also the same glass that takes away the heat, but not the daylight. So this was just standard float glass, 2 times float in the past, and in the renovation it had to look the same. But instead, in having modern solar control glass, the environment got so good both in winter and summer that now it's rentable space. So actually replacing the glass created 2,000 square meters of rentable space. And here is also the thing I like to show from the inside, how it looks. And you see the open door. It's not a big transformation of the colors. All these 3 concepts can actually be studied closely out at UPB factory in Liepaja, because they are building a project called Hästen in Stockholm at the moment, in central Stockholm. And it has the E-Class plus E-Class as the shop front. In the residential part, you have the SKN 183 plus E-Class, and then in the commercial, it's Extreme 7033 plus E-Class. So that's the darkest glass. It's all on low iron glass, and I think it's going to be really beautiful. I've seen the first pictures. So next question, can we rely on just one supplier? I mean, I worked for the same supplier for 26 years, and I get paid every month, so yes, you can. We sell to glass processors that make the insulating glass units for the houses. And all these companies around the Baltic Sea is where that are companies that buy our products. So you can get offer from multiple sources, even if you use just one glass suppliers. So moving on to science and number crunching. This is the not so fascinating part with not so many pictures. How do you create the combination of daylight and thermal comfort? Well, first, glass is about spectrophotometrics. What wavelengths do we transmit and which ones do we reflect back? And then you need to think about the different types of radiation. What we emit here today is we're black bodies between -50 and +100 degrees by definition, and we emit very long wave infrared energy with low efficiency. And that's what we're trying to stop from getting out of the house. What we try to stop from getting into the house is instead the solar energy, which is a black body at 5,500 degrees. It has more than half of the energy from the sun is invisible. It's infrared, it's heat. But it's not the same infrared as from what we're emitting. So it's completely different energies, and we need to handle them differently. All the glasses that I show here reflect back this energy by 97 to 99%. So it's not the problem really anymore. If we start out by focusing on getting the highest light transmission, we're at about 75%. a triple glass unit that lets in a lot of energy. If you remember the spectral curve from the sun and compare it to the spectral curve of this glass, you see that everything goes through, and it brings really nice colors. The bad part is that you need outside shading if you're in at least in the south, east, and west, to control the energy. And, you know, light matters. These are pictures from Oslo. And it says 72%. And that is a calculation that was made in a building simulation program looking at how the sun acts in Norway and what the algorithm is, the standard one for controlling these shadings. And it turns out that in this building, in a south-facing window, these shadings will be shut for 72% of the time of the full working year. So all the working hours of the year, 72%, you will have it closed. So what other solutions are there? Well, solar control glass is something that I like, as I said before. And the lightest one is actually, nowadays, it's the same light transmission, more or less, that we had in standard low-E glass some 10, 15 years ago. So that can be used, and this glass I use a lot in schools in Sweden. So to think, if you have a classroom, you can manage with inside shading devices. Whereas if you have a smaller room for smaller groups, you need an outside shading. But you can have the same glass all around the building. And then moving to the glass plus inside shading, which I will get back to a bit. You go down further in light transmission, but you also go down a lot in energy transmission. And you create a glass, if we look at the spectral curve, where the transmission is actually only daylight. So there are, of course, convection and stuff, but the way the coating is designed, it only lets through daylight. And that has an interesting effect on the operative temperature. Here I sit the first time behind extreme 7033, and I say light without heat because it's 26 degrees outside on this day. And I'm getting a reward, and I'm being interviewed. It's COVID, so it's recorded. So I have my 15 minutes of fame. I'm sitting there for like 15 minutes. And I don't really sweat, because the infrared energy that is gone from the sun means that I can actually endure it for quite a while. So basing facade solutions on this type of modern solar control glass makes them more resilient. So it's not like immediately when the curtain is gone, it doesn't work anymore. And then for modern houses, we can, of course, go with only a solar control glass. But the energy demands these days means that we go quite far down in light transmission. But then we get to an energy transmission below 20%, and for like an open office landscape or a classroom, that's usually what's enough. If you look at the spectral curve, it looks really wimpy compared to the other two. This is what goes through. If you look at bright red light, none of it comes through. And I want to show a reference from the inside, where to the right is extreme 7033, and to the left is extreme 5022. So you get like an image of how much more bluish it gets. So I like the middle curve in this. I put them on top of each other. By taking away a little bit of daylight, you take away a lot of heat. And then if you want to continue to take away heat, you do that only by taking away daylight. So I use only 5 things in my life, at least my working life. And it's these glasses, so you can have like a falling range of light transmission, and then you'd need different tools to control the heat. So outside shading exterior screen is like not big science. Anything you hang in front of a window will block out the heat. Inside shading is a bit more tricky, and I treat it in my next slide. It's been done with the help of Equa Simulation. It's a building simulation software producer in Stockholm that produces the software Ida Ice, which some students use in Latvia. And it's also used a lot in Scandinavia, Finland, and DACH. It was actually founded back in the 1950s. The first software was written hoping that one day a computer would be purchased to Sweden. So the roots are deep, and it was made to sell these mechanical ventilations that came back then with heat recycling. In the most modern versions, you can calculate wavelength by wavelength what energy goes through the glass, what energy is then reflected back from an inside shading. And when you do that in accordance with the European norms, you can see that you actually cut the energy transmission in more than half. There are some drawbacks to this theory, but it gives a new way of treating the energy. And I have made it slightly bigger, the 0.15, because a consultant friend told me if you design a room that cannot sustain 15% of the energy from the light coming in, then either your window is too big or your room is too small. Also, I have two different products. They're the most efficient on the market. They're not Saint-Gobain products. The most efficient is with PVC, and then the next one is without PVC. So that's also a choice to be made. Moving on, I don't see a problem in making a facade that can sustain winter cold. So thermal comfort in winter is more or less solved if you use the right combination. So I will skip to this slide to show the Magazine X in Uppsala, which was, I don't know what you call it, but it went into use 5 years ago. And you can see the glass. You have either 900 millimeters wide or 1800 millimeters wide and 3 meters high. So that means that you have very little frame compared to the glass. And then you can make what's called a flexo analysis to see in every point the outside temperature and the inside temperature. And this is important because when you drop very low in the U value for the facade, the heating does not turn on until it's freezing temperatures outside. So any cold bridge will become a problem because it gets the air circulating, and you might have to increase the temperature in the room by several degrees just to counter that. So cold bridges is like a thing to be avoided, and small windows are not sexy. So what does influence the window-to-wall ratio? Well, I say orientation, room size, and cooling. And I want to give a few examples to that. First, Regionens Hus in Gothenburg. It has, of course, 70-33 glass and inside shading. And it also has a cooling system based on air that can give comfortable cooling at about 20 watts per square meter. The office space is 7 meters deep, and that's sort of a standard in Sweden, and I think international, to have 7 meters office space, 5 meters of meeting rooms and kitchens, and then 7 meters of office space. And the equation brings about a 40% window-to-wall ratio seen from the inside. This is how it's seen from the outside. Two things to notice. You don't really notice the inside shadings, and when you bend the glass, it actually becomes a lot more reflective because it reflects so much more of the surroundings. So 40% is a bit small, 60% is better. And this is Merkurhuset in Gothenburg, which had the same prestigious award 2 years ago. I won it 2 years on straight. It has what's called cooling baffles, water-based cooling, and then you can go to 40 to 60 watts without having problems with draft and stuff. And with the same 7 meter steep office landscape, we end up with a 60% window-to-wall ratio from the inside, which gives much better views to the outside if you're in an office landscape and a bit further away. And it also gives this very nice matrix of brick and glass. And I see an advantage in modern solar control glazing that it's not low reflective and neutral in color, because this looks like a brick building with big windows. It doesn't look like a glass and brick facade. So cooling, that's a bad word for many people. Cooling loads, oh my God. So I want to take the example of how you can handle that. And Magazine X, which I had before, is like the largest fully timber project in Sweden. It was. Even the elevator shafts are in timber. And so it's a timber structure, so low embodied carbon. And it has building integrated photovoltaics, which is like modern, super modern. What actually drives the whole system is the geothermal part. It's like 30 holes, 350 meters deep. So they take care of the heating in the winter in a quite good way. But they also help out in the summer. And here's a bit of a complex diagram where you think surface. So the surface in the outer circle is consumed energy. And here you see consumed energy for cooling. Ooh. The inner circle is purchased energy. So the building integrated photovoltaics help, but also the geothermal heating, because you bring up cold water in the summer and cool the building. So here is actually purchased energy for cooling. So there are ways of getting to cooling, and we need cooling in buildings today because we cannot only rely on nighttime cooling. For Magazine X, since the office landscapes are actually 12 meters deep, you can have a fully glazed facade. So do we always have a fully glazed facade? For this building, there are individual solutions per facade. Northeast and northwest managed with just the glass. Southeast managed with just a very dark glass, and the combination of glass and shading is to the southwest. But what also happens is that while it's fully glazed, more to the north, to the south, the window-wall ratio goes down to 67%. And that is to not admit too much heat into the building. And here the black parts are actually building integrated photovoltaics. And that's also my answer to, do we need transparent photovoltaics? No, because in the directions where we have the sun, we can't have fully glazed facades, so we can use the spandrel areas for that. Looking at the solar shadings from the inside, it's good with the interior shades because you don't have the glass reflection before you have the shading, so you have a better view to outside. These are light gray. You're starting to move a little anxiously. I'll speed up. 3 minutes? Perfect. 3 minutes, good. You can try and get your microphone moving then in the 3 minutes. Perfect. If you want a better view to the outside, you need as dark as possible a curtain on the inside. So this is actually our home on Öland. And here is 2% openness factor in the curtain, black inside, because it's to the north where the good view is. And here is beige inside because we wanted to match the panel. Here is like low E glass to the north, here is solar control glass to the east. So this one we can actually raise when the sun is gone after a few hours in the morning. This one needs to be down all day because of the blue sky actually gives you some 200 watts per square meter. In conclusion, you want to have either the cheapest solution for a facade is to have a static solution with light solar control glass. And then the second cheapest, best for me is a dynamic solution with inside shading and solar control glass. And if your room is too big or your floor, if your room is too small or your window is too big, then you can go to outside shading. Quickly moving from low-carbon design to low-carbon products. Flat glass can only be made from old flat glass. And for containers and bottles, we hand that in. It's remelted into new bottles. But flat glass is too cheap and too difficult, so it's all going to landfill today. So that means that we have a higher carbon footprint in flat glass than in bottles. And we want to change that. So we have developed a product where we can use some 70% of old glass, because then your melting point goes down, your need for primary material goes down, your carbon footprint moves down. So by going from a maximum of 1/3 of broken glass to 2/3 of broken glass, we can save a lot on the carbon footprint, 42% for ORI so far. And we've sort of exhausted all the cutoffs that we get from producers and what we produce ourselves. So we want to produce everything in this way, but then we need to start collecting, and we have several programs going for that, to collect old windows to make new glass. So that's sort of in the cards for the future. By 2040, 2045, we need some 850,000 tons of end-of-life cullet every year. It's realized already today. So Habitat 7 in Gothenburg is a project where after the steel and the concrete was gone, the big source of CO2 was glass, and then that was also reduced with ORI. And that's my final. Thank you. As I said, I have a few books. If anybody wants one, you can approach me later. I will bring them down from stage with me.
Okay, thank you. Thank you for your speech. So I welcome you for a few question session. And as I understand, you've been in the glass business for a long time, and you are dealing both with technical and aesthetical issues. So might I call it you glass architect?
Glass architect.
Yes.
Yeah. I think a lot about how light falls in through glass and how that causes either reflection in the glass or transparency. So I just released a 10-page article on that in a Swedish magazine. So I'll need to translate it into English.
This is modern now to write books. Do you intend to write maybe some thicker article about glass?
I have written about 20 articles on glass.
Now you can gather them in a book or something?
Yeah, that's the plan, or to publish them one by one on LinkedIn and then maybe a book. It won't be printed because we don't do printed material anymore in Saint-Gobain. We try to avoid it for the carbon footprint.
Okay, so every architect has an ambition normally. Someone wants to build some particular buildings, some other wants to build in some particular country. Do you have any ambition as a glass architect?
Well, if you Google Tryggehuset, it's a barn that was renovated by my mother-in-law in 1980 that we renovated the last few years with different glass and shadings, because I hate overheating, so it's a passion of mine to paint doors white or put in curtains or use these passive cooling systems.
So, but you have your like Saint-Gobain or some other special glass in your home?
I have all the glasses I presented in my home.
So every window is different?
What?
Every window is different?
No, actually, I don't have the SKN 183, but to the north, I have the E-Class for the perfect view to outside. East-west is the Extreme 7033, and we preserved some old windows, and there we had to put like a hard coat low E glass behind, because it's traditional glass connected windows, not insulated glass units. So there are like 3 types of windows.
Okay, so then I ask you another personal question. There is always some trigger why you enter the business. then why you are still in this glass business?
Well, the old thing is to say that I'm really shit at job interviews. But a more balanced answer is to say that once you've entered the glass business, you don't leave it. I still find it very fascinating, and I mean, before retiring, I could never get to the same level of expertise in any other business.
Okay, but is there something you haven't solved yet? I mean, is some issue about the glass and all these technical aspects that you would like to solve, but this is not solved yet?
Well, it's like the legislation of some countries say that you need tons of daylight and you need good thermal comfort and you need no cooling, and it's sort of all directed to this thing that you need to hang something in front of the glass. And sort of my passion is to see how far can we twist it before we need to put something outside the glass.
So you don't like curtains?
I like them on the inside, not on the outside. Where do you put your curtains at home?
I will. Okay, Oskar, thank you very much for this inspiring and very knowledgeable presentation. And I think that we have a Saint-Gobain representative here in Latvia. We can
Not
address
today,
him.
he got ill, but I have a partner from UPB with me today who is chaperoning me, so I won't get lost on my way to the airport and stuff.
Okay, thank you.
Thank you.